Just wanted to give a brief about what we'll be discussing on the session today. But before that, let me introduce myself to everyone. I'm sure I've worked with quite a lot of you, so you would know me. This is Sheetal. I take care of operations within Anamind. I've been with Anamind for quite a long time now and have an expertise in Forecast Pro. So this is what we will be doing today. Now we have started with Forecast Pro learning series where each month we'll be picking up few of the topics which are really important for our customers, and we'll be using and showcasing the usage of those features on the Forecast Pro solution. Now, before moving towards Forecast Pro, today's topic, which is related to forecast accuracy, the waterfall report, and the machine learning model, I'll walk you through who we are as Anamind so that, at least the newcomers would know who we are and what we do. So we are all about business planning and forecasting. We have various solutions, services, and educational program for business planning and forecasting. Some of you are already using Forecast Pro, so that's part of our solution uh, portfolio that we have. We have other solutions as well, which can do much more than demand planning and forecasting. There are solutions that we have which can do inventory planning, production planning, and as well as financial planning and forecasting. So we have a comprehensive suite of solution which can do end-to-end planning. Now, Forecast Pro is one of the solution which is very focused toward demand planning and forecasting. It's one of the best solution out there for demand planning and forecasting. And I'll talk more about Forecast Pro in a bit, but I'll also touch upon the planning services and the education part. Now, within planning services, we also offer our service as an outsourced service engagement where companies do reach out to us, take our expertise in generating the forecast for them because we have the expertise and the solution. So we help out clients on that. On top of it, we also create a lot of analytical report for our customer using Power BI and other solution. So that's in the service side, and in the education, we have the training program where we offer comprehensive end-to-end planning training program, typically oriented for demand planners, supply planners, and the sales team. This is the overview of the various solutions that we have. Today we will be discussing about Forecast Pro, which has in-depth features for various scenarios which are part of your demand planning process. All right, now to talk about Forecast Pro. Forecast Pro is from a company called as Business Forecast System, founded in 1986, and we are their official representative in this part of the world. And Forecast Pro is one of the oldest solution for forecasting, and it has a comprehensive suite of features for forecasting. In fact, it can be used off the shelf. It's been implemented across the world with more than 40,000 users worldwide. So it's quite a solution that you can use for collaboration and for demand planning activities. Okay, let me walk through the waterfall report. So this is one of the report that's been not sure if you all are using this report, but this is one of the most insightful reports within Forecast Pro that we have. And we really wanted to cover this report in detail so that you understand and can also make use of this report effectively in Forecast Pro. This report is available for all the users of version 5, version 6, and version 7. Version 7 is the latest version of Forecast Pro that we have. So even if you're using version 6, you would be able to look at this report. I'll talk about it in a bit, but let me discuss what you can actually achieve or what does Waterfall Report can show you or what kind of insight that it can bring in, or what kind of data that it uses. So waterfall report actually uses your previous forecasts, which is generated using Forecast Pro. You can compare that forecast with your actual demand in a waterfall like format. So because we forecast on a rolling basis, each month there's a new forecast that's generated. The months keep on changing because we are on a rolling process. So that's where the Forecast Pro uses the past archived forecast in the system to compare that with the actual. And there are a lot of parameters that are used to analyze the accuracy of your forecast, of the rolling forecast versus the actuals. So the first parameter that's the most important that we need to factor in, or that we need to look at, is my lead time, because that is the crux of this report, because we are forecasting on a rolling basis. So let me just walk you through that parameter and talk about this report. So we have this option of forecast tracking. I'll be talking about the waterfall report, which is similar to it, but it's important that we understand this report first, and understand what are the various parameters that are available over here. You also get to view this report if you're using version 6 or version 7. You will also get to view this report from here directly on the front page. Now, what is this? What kind of data is being represented here? I hope you're able to view the screen quite clearly, but let's walk you through this report that we have. Now it's saying that it's taking last 6 months actual data. In this case, if I would open my graph, this forecast graph that we have, or the actual graph that we have. So within the system, we have actual historical data till December 2019. And it is using the actual data till December 2019 to forecast for the next 12 period. That's how this report is, that's how this project is created. Now, what we had done, that we had gone 6 months back, and we were in the month of July with my actuals data till June. So in June, I had not in June, but once June completed and I had the actuals data of June, I had forecasted for the next 6 period, which is from July, August, September, October, November, and December. And that is the forecast that you can see over here. So with actual data till June, I have my next 6 periods forecast. Similarly, as I move forward, July gets completed, and then using the data till July, I was forecasting, or the system was forecasting from August, September, system was forecasting from August for the next 5 period in this case. So on a rolling basis, similarly, we move forward, we look at August completion, and based on August completed actual sales, we would be forecasting for September, October, November, December. And that's where my lead time is kind of varying for each month. So when I look at this purple or blue color highlights over here, these are my forecast with lead time 1. Essentially, what lead time 1 indicates that I am in July, I have actuals data till June, and I'm forecasting for July. So within July, I'm forecasting for July. That's what is this forecast all about. And that is being represented by lead time 1. When I'm in July with actuals till June and I'm forecasting for August, that's my lead time 2. So I have how many observation over here? I have 1, 2, 3, 4, 5. I have 5 observation with lead time 2, and that's what you can see over here, that I have 5 observation. For lead time of 1, I had 6 observation, because these are the 6 months that I was forecasting. Similarly, as we move forward, um, these are the months that we are looking at, and we have the number of observation keep going down. So that's what the number of observation on this screen represent with respect to my lead time. Okay, now within this report, I have three types of analysis. And if I go back to my presentation, you can see there are three types of analysis mode. One is series analysis, one is component analysis, and one is end item analysis. Now, within series analysis, it's very important to understand the difference between the three. But even before before moving towards understanding the difference between these three analysis, let's go to the setting and see what are the various options that are available to us. So number one, we have an option to either check this report, the waterfall report, in for my forecast or for my baseline or for my statistical number. So that's the option that I have over here. So we have selected forecast because that's the final number that's coming up. But if you are also collaborating with your sales team or some of the other team members, you can actually look at statistical one first and then the forecast so that you can see if your Mape or your Wmap, whether it's increasing or decreasing. All right. Now the report type is based on my forecast, but we also have an option for error where instead of forecast over here, it will show the error. And let me select that. You can see what's the difference between my forecast and my actual. That's the difference that you get to see over here. So that's the setting that's also available. You can actually track month on month how much error you are getting. So that's something that you can track. And similarly, we have percentage error. So you can look at the percentage error as well. But right now, I'll select the forecast for now. Now I have three analysis mode and I've selected all three of them so that you get an overall perspective of what these three analysis mean and how they are different. And then we also have period to display. So how many periods do you want to look at look at the information for? You can select that many month. Right now I selected 6, which is fine for me. But in case you want to look at 12 months and you have that data, you have that forecast archived for last 12 months, then you can use 12 periods to display as well. Rest of the information are not so relevant, so I'll not waste my time in that. But you can also say select the lead time. So when I'm selecting these lead time, I'm basically telling the system to color code these time periods. So if I would uncheck that, you would notice that the pink band and the yellow band has gone away. But it's really important that we activate them so that it becomes really easy for us to differentiate and look at these numbers in detail. Right. So the next option that we have is the average forecast. What is my average forecast with the lead time of 6? And that's what you get to see over here. So it will do an average of all the forecasts generated with a lead time of 1. So the numbers that I'm moving my cursor on, these are the numbers that the system is considering. An average of these numbers is what is being then reflected here. Similarly for, with lead time 5, it's taking what my average forecast is. And the next section, it's depicting the average error. So if I would say move to my error portion over here, the average error in each of these months is what the system going to factor in. And if you would notice, for the last 3 months, we had high negative error. And that's the reason my average error is negative, because initially I had very low positive error. Now it's for the last 3 months, I have high negative error. And that's the reason it's depicting in that fashion. So I can see that as well. Then it reflects the MAD value. And typically when we are, forecasting, MAD becomes the critical option for looking at and understanding any of the error parameter that we get, right? That's the error measurement technique that we have, which works pretty well as well. Now, in this case, it's taking, and all of this report, mind you, I've selected consumer goods from my product hierarchy, and that's the selection that's getting represented over here. So I'm actually looking at the series analysis at consumer good level right now. I'll move to the rest of the section as well and talk about the product hierarchy, but that's for a later stage. Let's look at the MAD value. Now, how the system calculates the MAD? It basically calculates the difference between the forecast and the actual. Because I'm in lead time 1, I'm going to take that example. So the difference between my actual and my forecast with the lead time of 1, it will take the absolute difference of between the actual and forecast with lead time 1 and divide that by the number of observation. That's the formula for my MAD. That's the mean absolute deviation over a period of time. Now, if you would look at the lead time 6, because we have only one observation over here, which is 4103 versus 4605. So the difference is 502, and my average error, my MAD is the same. Only the difference is on the signs, which is either it's positive or negative. Mean absolute deviation is always positive in nature. So that's what you get to see over here. The next section is my Mape. So Mape is again a very simple approach over here. How is the system calculating the Mape with 6 observation with lead time 1? It is calculating the MAD for each of these observation. Then it's dividing it by actual. So that's the mean Mape formula. And I have also copied this over here just to show you how the difference would look like. And I'll take it with a lead time of 6. So in lead time of 6, this is my forecast, because with June actuals, I had forecasted for December. So that's my lead time 6. And this is my forecast and this is my actual. So that's the absolute difference that I have. And if I divide this absolute difference by my actual, that's my percentage. And if I would look at the Mape over here and here, it's almost similar. The difference could come because of the decimal values over, in my forecast. So that's what you get to, that's how the system is calculating the Mape. Now, if you would have, two observation, that's what we have over here. So let's calculate the absolute, sorry, let's calculate the absolute difference first and the Mape for this lead time 2. Because we have 2 observations, I need to factor both of them. Less. So I'm calculating it for November and December divided by December. The average of these two is 7.39. And that's what my Mape over here would represent. I hope that's clear to you all. And similarly for lead time 4, lead time 3, lead time 2, the system would be calculating the Mape accordingly. Now, the next option that we have over here is the CMAP, which is my component Mape. Now, how is the component Mape getting calculated? The system is calculating, and I'll take this example because this has only one observation, so it's easier to understand. So with lead time 6, we are going to look at the CMAP. So in CMAP, system is trying to calculate that how much weight consumer good has in the next level, which is my India level. So I'm totaling all of the different categories over here, or the business unit over here, and calculating how much is my component weight. In this case, it's 1%. So I'll have to multiply this component weight because consumer good is only contributing to 1% in the month of December to the overall sales. If I move to a different example, maybe, yeah, in this case, food and beverage, for example, food and beverage is contributing uh, the average sale of food and beverage is 19% to the overall sales in the month of December. So if I look at my Mape, which is 5.32%, I'll take my calculator so that you get to see 5.32, and I'll multiply that with my weight, which is 19.92. And that is 1.06. So I've just taken, I've not considered the decimal factors, but you can see it is 105.9. If I just round it up, it will be 106. So that's the value that you get to see over here, that it's 1.06. So that is what my component weight is. Again, this is very important factor because I would want to give more importance to an item which is contributing highly to my sale, right? And that's what the component weight over here represents. Similarly for the rest of the items as well. Now, let's move to the end item analysis and component item analysis. And to be able to understand these terms, what we need to do is look at my product hierarchy. So in this case, I have a product or I have a company, and the option is basically set up in this fashion. So I have a company. I'm going to look at my electronics. So this company is being bifurcated into chemical paints, consumer goods, electronics. Electronics is further segregated into laptops. Then we have some location. Then we have these different SKUs being sold in different locations altogether. So for consumer good, at consumer good level, the next option that we need to look at is the components of my consumer good is electronic and furniture. So electronic and furniture category together form are the component of my consumer good, and that's what it represents over here. So in this case, when we look at the component analysis, because I have only two component over here within consumer goods, so I have total 12 observation with a lead time of 1, which is 6 observation for electronics category in lead time 1 and 6 observation of furniture in lead time 1. And total it is 12, then 10, and then 8 and 6 and 5 and 2. So that's how it's going to calculate the values over here. And then the MAD value. So MAD value of my component. So how it's going to calculate the MAD? It's going to look at what's my electronic forecast. So let's look at December month again, because that's the most easiest month. Now what's my, and I'll take my calculator again. So my 2734 is my actual, my forecast is 2371. That's my forecast. So I have an error of 363, right? That is for electronics, 363. And for furniture category, my forecast is 32 less 1871. So I have 139 as my difference. So if I calculate 139 and 363, that's the so I have a total of 502. And if I divide that by 2, then it's 251. So with a lead time of 1, I have 2 observation for my electronic and furniture, and the MAD value is 251. So it's the average absolute error for those 2 observation. That's what the MAD value represent. I hope that's clear to everyone. Now moving on to the next option, that is my Mape value over here. So it's coming to be 10.34%, and let's look at how it's calculating the Mape. So what it is trying to do and what we have done over here is, yeah, so I've calculated the individual MAPE over here for each of these months. So I have 363 as my MAD value for my furniture, sorry, electronic category. And for furniture, my MAD value is 138 or 139. So now if I take the MAPE for that. So for MAPE, I have to calculate, I'll be calculating 363 divided by the value for December for electronic and similarly for furniture. Now the MAPE for these two would be the average MAPE. So we need to take an average of the two values, and that's what it's going to represent over here. That is 10.35. Again, some decimal rounding error might come up, but over here, or in this case, you can see it is 10.34. So I'm going to take an average MAPE for this section. So I can actually take an average MAPE from here for furniture, sorry, for electronic and furniture, and the average MAPE would then be used at the high level to represent. So that's, so in this case at consumer good level, I can get to know what's my average MAPE. And for WMAPE, and that's the most critical feature that's used, company wide or, industry wide, that we have seen that the companies utilize the WAPE factor more than the MAPE factor, because in MAPE we're not taking the weight as per the actual sales of each individual item. However, we are just averaging the MAPE without considering, if one item which is of low volume is contributing to higher, then it's going to give an equal weight to everything. But in WMAPE, we give a weight of the of each of the individual component, which is my electronic and furniture. And let's see how we calculate the WMAPE over here. So WMAPE, to calculate WMAPE, what we do is we calculate the absolute. So we calculate the absolute error, and we aggregate that absolute error and then divide it by my total forecast. So my total actuals is 406 and my total absolute error is 502. And I am using that value to be able to derive my WMAPE, and that's what you can see. Of course, there is a slight difference in the decimal values, but then that's okay because of the slight difference. That's fine, but then that's how my system is calculating the WMAPE. And this is the important factor that we have seen companies utilizing globally using the WMAPE. So that's what you get to see, and I hope the component analysis is clear to everyone. Component means the next component values are taken into consideration to calculate the error. Um, and then we have the end item analysis. Now, how do we do end item analysis? We open up the hierarchy to the last level. In this case, we have, this SKU getting sold in Bangalore and Chennai. So the individual error at this level is being calculated and being reflected in consumer goods. So all of the end items that I see over here, the error at that level is being used to be able to present the observation over here. So in this case, let's look at a simple example. Yeah, so in this case, I've selected warehouse one, or let me select smartphone. I think that will make more sense. So I have 4 items over here, right? I have 4 end items within smartphones. So 4 is what my 4 is my end item, and it could also happen that I might not have all the observation. In this case, Chennai only started uh, in November and December. Let's look at this case as well. So now when I go to smartphone for lead time 1, I would have only how many observation? I would have one observation over here for Chennai, and for rest of the items, I have full observation. So 3 into 6 observation. For each of the series, I have 6 observation with lead time 1. So that is 18 because I have 3 full items. And then for one Chennai location, I have only one lead time factor. So that's what my end item analysis over here would reflect, that I have 19 such items or 19 observation for lead time 1. And similarly, it will move forward for rest of the points. Again, MAD would be calculated at the end item, and that's what the mean absolute difference would represent over here. And similarly for MAPE and for WMAPE, again, the average absolute error is being first calculated at the end item first, and that is then aggregated and then it is divided by the actual value for the respective month. That's what the WMAP over here represent. So this is the waterfall report, and with just one click, if we are at India level, you would be able to get to see what's my end item. MAPE is, WMAPE is what is my component within the series, the component, what's the component WMAPE is, and everything. That's the power of the solution that you can see over here. You can also not only flip the hierarchy, because majority of the companies look at the SKU level, accuracy. So what you can also do is you can actually move up the SKU slightly, and I'll do that. And then I can actually see the component analysis at the individual SKU. Let me talk. Yeah, so now I have India. I've changed my product hierarchy. I have India, and within India, I have all these SKUs. And then the component analysis and the way WMAP over here would represent the error or the MAPE, which is calculated using the SKU level details. So that's what we have over here. You can actually flip the hierarchy and then look at these values quite effectively. And similarly, we have the waterfall report over here in an Excel format. This is more in the graphical format. Over here, you would have all your items, all your hierarchies, and whatever hierarchy that you would have set accordingly, the hierarchy would change in the report as well. So you can activate the filters over here, and you can actually look at the component analysis. So over here also you can define, you want to look at component analysis, or you want to look at any of the other information. So you can select that, select all of the options that you get to see over here, and say click OK. And you can export out the report. So if you want to look at the details at India level, then that's available. You can select the lead time. Let me cancel. So you can also select the lead time from here. You can define the lead time, and you can of course, all of the Focus Pro user would know that you can export out this report to Excel and look at the details in Excel for further analysis if you want. I'll take a pause now and see if you have any questions right now, or if you would want, we can take up the questions at the end. But if you have any of the if you have any questions related to this report, feel free to ask. We want to keep the session interactive. Else, I'll move to the second section of the report.
Sheetal, hi, Rohan this side.
Hey Rohan.
Hi, just one question. When we are referring to number of observations,
Mm-hmm,
what is that supposed to mean, and how is that? We were looking at MAPE and taking an average in case the number of observations were two.
mm-hmm,
What
mm-hmm.
is this? What is this frequency?
Okay, so let me go to the Excel. I think that will help you understand, or maybe let's look at this report itself, right? So in here, I have 6 observation, right, with the lead time of 1. That's what it is being showcased over here. And I'm going to take the series analysis, which is at India level. Now over here, I see my actual values are for the last 6 months because I have selected that I want to look at 6 months, past
Hmm.
6 months. So these individual 6 months are getting reflected over here. Now, when I'm in June, I'm forecasting, sorry, when I'm in July, I have actuals till June and I'm forecasting for July, correct? So that
Mm-hmm.
is my lead time 1. So
Got it.
this is my first observation. When I move and I have data till July and I'm forecasting for August, I have another observation of lead time 1.
Hmm.
And similarly for when I complete August, I'll be forecasting for September with actual data till August. So till August actual sales data, I'm forecasting for the next few months. And because I have data till August, actual data till August, and I'm forecasting for September, I am going to look at my September as my lead time 1, this forecast as my lead time 1. So for lead time 1, I have some, in this fashion, I have 6 observation.
Got it. And how was it playing a role in MAPE? So my understanding is if we are looking at MAPE with the actual data, it will be
Mm-hmm,
looked at the whatever lead time interval we want to report MAPE. Let's say a particular SKU has a 4 month lead time. We would want to relate it to a MAPE over a 4 month lead time period.
mm-hmm, mm-hmm.
Like
Right.
in July, if I order, I get it in October, then I should be looking at that 4 month lead time MAPE. But
Okay.
let's say it's a 1 month lead time product only, and there are 6 observations of actual against 1 month lead time forecast. Then why are we
Mm-hmm,
taking average in MAPE? When I joined in, we were looking at taking average of 2 observations if the observations were two.
mm-hmm,
Is
mm-hmm. Okay. Let me, you know, put the formula over here. See, I have A item, I have B item, and I have C item, right? I have actuals, I have forecast. Say, I'm just going to take random values. 175, that's my actual. My forecast is 125. My take absolute deviation to take the sum of my actuals. So now my MAPE formula, in this case, if I look at individual MAPE, for individual item, this is going to be my MAPE, correct?
yes.
And if I want to look at overall level, then my MAPE would be an average of, typically, I'm talking about the pure MAPE formula, which is being used in Forecast Pro. So this is my MAPE. There is also something called as Wmap, which typically I believe you also utilize in your company, where we actually aggregate all of the data, all of the absolute difference, and
Hmm.
then divide that by actuals. And that is slightly different to my average MAPE. So MAPE is typically because it's mean absolute. You're trying to take a mean of your absolute percentage error. So you're actually giving equal importance to all of the item and not their actual weight. But in Wmap, you give importance to the actual value of each of the individuals item as well. So this
Got it. So
is
if it's multiple SKUs, then we'll take average for reporting MAPE. For a single SKU, the number of observations were not
correct.
used for coming arriving at any average or
Right.
MAPE. Okay, okay.
Yeah, yeah. So over here, now when we look at this file, for example, because we have 6 observation, we are
Mm-hmm.
actually taking the average of those 6 observation, the in that case. That's the reason we are dividing over here by 2, or we're taking an average, for example, in this case.
Which two observations were taken here for arriving at the
So in this case, because I was looking at lead time 6, so I had only one
okay.
observation for in this case. So I'm taking um, basically this forecast, sorry, this actuals in this forecast
Mm-hmm.
in this case. So so because this is just one item, so my MAPE and WMAPE is going to remain same,
Mm-hmm.
uh, right? But if I'm going to look at, for electronic and furniture together, these are two components which form consumer good. So if I
Okay.
want to know at consumer good level, what is my MAPE for my component, then I'm going to do an average, which is in this case 10.35, and that's what you get to see over here for the month of December.
Yeah, yeah, got it now. So two were categories within, and hence the average was taken.
Correct. Yeah.
Okay.
Okay. Any other question that you have, or anyone else? Okay. So we had also covered the waterfall report. Uh, you can actually filter in the details as per your requirement and take it out in Excel and use that for later. For forecast accuracy report, again, this is of course widely used report that we have. What I wanted to cover in this report is lead time and the hierarchy part of it, and then the way we can analyze my forecast with respect to my forecast type and my value add. So lead time is something that we have already covered. Now we have an understanding of what the lead times mean with respect to each of the month. And then when we look at hierarchy, and that's what is more critical over here. So I'm just going to look at my forecast accuracy report that I have. Now, let me close this. Yeah. So in this case, because I've changed the hierarchy on my on the Forecast Pro. So I've brought in all the SKUs at the top level first. And honestly, in some companies, they look at country SKU level number. So you can actually create your hierarchy in the way that you would want the data to be. And you can, it just saves time for you to look at and download the report and, do other analysis on top of it. So over here, what we can do is we can activate the filter, and supposingly you want to look at your SKU level numbers only. In this case, what you can do is you can, uh, from the division side, which is my next level, you select null from the next level. And from SKU level, you select all the SKUs and deselect the null. So now I have my forecast with a lead time of 1 in this case. I'll go to the setting part in a bit, but I have my forecast with a lead time of 1 at the SKU level. And remember, this is my reshuffled hierarchy. Earlier, I had my chemical and my consumer good categories first. So for the month of December, I can individually look at my historical sales number, my forecast, and the deviation over here. Now, if I go to the setting part, which was my second component, I've covered the lead time and hierarchy, but I wanted to now cover the forecast type. So what do I want to compare my historical sales data with? Do I want to look at my sales data or my statistical number? Or is there anything else? So I can do that. I can change my lead time. And if you would want, system can allow you to actually accumulate the forecast and actuals for the say in lead time 2, you have 5 observations. So it will actually, if I check this box, then it will accumulate my forecast and accumulate my sales data for lead time 2 for the 5 observations. So what is my start date? What is my end date? Let me change my start date. You can select my the start date as well. And when you do that, it's going to combine the actual sales data and your forecast data, and it will give you, how many observations are there, are you combining for that respective item. And then you can look at your combined stat number and the deviation and all of it. So you can export this report and, do your further analysis if required. Or you can tell the system that you do not want to combine it, but you want to look at each of the respective months. So you get to view all of the respective months for with the lead time 2 in this case. So we have one stat forecast and then we have the final forecast for comparison. For value add report, I'm going to move into another example that we have over here. Now, what happens that, we follow a cycle, uh, a consensus process within the organization. And we might be utilizing the forecast grid in that case. So we have some stat forecast coming in from the system. And let me look at this example. And then, there would be some input that would come in from your demand planners or from the management or from the sales team. So you can have all of those, rows created within Forecast Pro, and Forecast Pro would, help you track that information at these levels. So this is my forecast, this is my actual. So once we would complete September, system is going to allow you to calculate what's the stat number, the demand planning number, and the final forecast number, and what is the forecast error that we have, and how much value add did the demand planners or the management or the sales team had with respect to the sales number or any of the number. So ideally, when we look at a process, the process should move in such a fashion that it improves the overall accuracy. So in this case, my actual and the actual is 32,000. So let me first walk you through where you can find this report. So you have this report over here, which is forecast value add report. You can look at the actual, the process, and then it follows the process step. Naive, let me deactivate the naive forecast for now. Yeah, then we look at the statistical numbers. So system generated a stat number of 29,000. So my forecast error was 7%. If I look at the demand, the information that came in from the demand planner, it was 35,000. So they increased the forecast from 32 to 35,000 or almost 36,000. And that increased my error to 11%. So when I look at my value add with respect to statistical, I actually reduced my forecast accuracy. If it had been closer to 32,000, then it would have really improved the overall forecast accuracy. But over here, there was a negative value add from the demand planner. Similarly, from the management, it further increased to 38,000, and that's the reason we can see with respect to statistical, my forecast error is, it has increased, and it's 14%. And over here, we look at, we can also activate and look at, if I want to compare my demand plan number with respect to, with respect to the management number with respect to my demand planner, I can look at that as well. So that's what is being represented over here. So minus 9% is how much value add did the management do with on top of my demand plan number. And similarly my forecast. So that's the value add report, which you can also look at, just to check overall how much improvement is the sales team or your other stakeholders in the process are doing, right? Okay, let's move to the final topic, which is the forecasting method, and we'll be talking about the machine learning method today. Now in Forecast Pro, we have various techniques, as you know. So we use expert selection method to for the system to be able to calculate the best fit model based on the individual items actual sales. So there is a recent addition that was done by Forecast Pro last year. That was a machine learning model. And let's talk about the machine learning method which Forecast Pro utilizes. So we have an extreme gradient boosting regression tree method, which is being utilized by Forecast Pro. And this option was selected based on the results of market Dockers competition, which was held in 2019, I suppose. Yes. And the M5 competition, which is a global forecasting competition. So based on the results, where a lot of companies would come and use their forecasting technique and see what model is giving best result. So Focus Pro team realized that this particular method can actually help in overall improvement of your forecast accuracy. So they have incorporated this technique, and what does this technique do? I'll be discussing in a gist over here. But there is a complete in-depth video by Forecast Stream, and I would highly recommend you all to look at that video to get a detailed understanding of the model. But just to talk at a high level, what does this model do? It builds regression trees, and based on the regression trees result, it will average the error, or sorry, average the forecast based on those uh, outputs from each of the regression trees. So let me get into a depth over here. So typically machine learning model, there are unsupervised technique and then there are supervised technique. Unsupervised techniques are typically for image comparison and all of it, but for demand planning, we used a supervised ML model. Now in supervised technique, there are multiple factors that we can look into it. Now for forecasting purpose, typically the factors that have an impact on your sales could be your last month sales number, could be your last year same period number, could be in which month you are. So the seasonal factor there, the year, which could be if there is an year on year change, there is an year on year increase in sale, year on year decrease in sale. The interventions is what is called in Forecast Pro, but then you can take that as year. So with the time series data, all of this information is easily available for the for this method to build trees. So what does it do? It takes into account, okay, which month are we in? Which month are we forecasting for? Are we forecasting for November? Then it will build a tree on that. So it will take, okay, yes or no. So just a simple approach could be, is the forecasting month greater than 6? If yes, then it will move to this option, the next option. If it is no, then it will give some result. But if it moves to the next option, then it would look at, okay, was my actual sales last month so much? Was it greater than or was it less than so much? Then if the answer is yes, it will move to the next step. And then similarly, it will keep on building the regression, these trees, till it realizes that it is no more leading to an increase in forecast accuracy. So there is an optimization technique within Forecast Pro, which automatically detects the optimum level of these branches and the tree depth that we have. So based on each of the input that it that comes in, based on each of the tree that gets created, it will take that into account and see with the training set whether it is improving the forecast accuracy or it is not. If it's not, then it will stop right there. So, and based on these, result with each of the options, it will use that option to basically calculate the forecast for a particular month. I've told you at a very high level just to give you an understanding of how the solution is trying to calculate all of these factors, how the system is basically incorporating these factors to calculate the forecast for each of those months. I'll also walk you through one of the example quickly, very quickly. You can look at the forecast report. I'm going to look at this method. So now in this method, the system is automatically picked up a machine learning technique. So we have the machine learning component activated in the options. You can unselect it in case it's increasing your computation power or it's taking a lot of time, because it needs some time to analyze the data, analyze all of these factors. So it can be a little time consuming, but however, we have not seen anything that it can't hold. So now when it uses machine learning technique, you can see it depicts the tree depth and the number of tree used. Now, what is tree depth? It Tree depth indicates that how many branches did it, how many levels did it go through to arrive at the answer, to arrive at the results. So in this case, if the option one was yes, and then further option one was yes, then I went through two level. So that's what it is being represented over here. And number of trees is, how many answers do we have with respect to each of the options. So that's what my number of trees could be. I'm so sorry. Number of trees could be the number of trees that you would add to arrive at a result. So, to arrive at a particular answer. Now, we have, if you just further read over here, we have these feature importance list, and it's really important to give a note over here. So what are feature importance? We have seasonal period, 1 lag period, intervention, seasonal lag, 1 year moving average. So ML model is designed in such a way that it is automatically predicting, which method or which of the factor is giving, best result, and that these are sorted based on my gain. Gain basically over here indicates that this component, which is my seasonal period, and seasonal period is typically the month information, how much this option is leading to an increase in my forecast accuracy. That is what is being represented here, and that's how it's sorted. So my month is one of the factor, and in this screen we can see that typically we see an increase in sale in a repetitive fashion. Typically, around Jan and December is when we see our sales going up. So there is definitely a seasonal trend. Then one period lag is again a very important factor. The interventions, it could be the spikes or the change in level that we see from year to year, the seasonal lag, and the 1 year moving average. So all of these factors have a contribution to my overall forecast accuracy. And then we have the coverage. So when we look at the coverage, it basically is the percentage of observation split of the features. The relevant basically tries to determine the relevance of each of the feature is to forecast each observation. Then we have the frequency, what is the percentage of tree nodes that split on a feature. So that's one part of it. That's really that these are the three parameters that the system depicts over here. And then what the system is trying to also help you with, or what are the ways in which you can actually utilize the ML model pretty effectively, is by also incorporating the events and my external variable. Sorry. What you can do is you can go to the manage option and say, for example, COVID had a significant impact on your sales, right? I'm just making it up. It could be the price promotion. It could be any of the event that you can create within Forecast Pro, and you can bring in those event schedule over here and use that for improving the forecast further. And similarly, any of the external variable. It could be the weather, it could be the economic indicators, or it could be any of the other information that you believe has an impact on your sales, on your demand. You can bring in those factor, and system will automatically calculate whether that factor has an impact on the forecast, on improving the forecast accuracy further or not. Say, let me create an event. I'm just going to create a random event one. Sorry. So I've created a random event and I'm just going to mark that for my for a particular month. And I'm going to tell the system that use machine learning, but use this schedule that I've created, which is for my price variation. You can see it is not even considering that event at all in my feature importance. But if I, create a different event, um, let's say this is one of my price factor that was important, and I'm going to select that. And I'm again going to go back here and I'm going to say use schedule 2 instead of schedule 1. Okay, in this case, it's not even selecting that. So because it could be a seasonal lag that we see over here automatically. Okay. So that's what it is. I'm sorry for taking up your time. We are time crunched today, but I'll definitely like to take your feedback and, able to topic in the next call. So please feel free to mail me and we'll be sharing with you the recording. And I hope the session was useful to you all. You can write your questions back to me and I'd be happy to answer them and take it further as well. But for now, thank you so much for today's discussion. Really look forward to having you in the next series as well, which will be scheduled for next month. All right, thank you. Bye-bye.
Thanks, Sheetal. Thanks.